Hi everyone, welcome back to another video where today we're going to be going through my predicted paper for tomorrow's Edexcel Applied. So this is going to be my last video for this exam series, and for all of those who have watched, I really hope this was useful. I've tried my best to create some difficult and challenging questions for you to practice with, and also target some weaknesses that some of you have come to me with. I really appreciate all of the nice comments that people have been giving, and just before we get started, I wanted to say that there are a couple of mistakes in this paper. I'm recording this after having completed the paper. So you can see them here. Question 3C, you'll see that it's 4 marks, but instead it should actually be 1 mark, which was a bit of a mistake from my side. And lastly, 7C, I worded it a bit poorly, and it should actually say show mathematically that the stone hits the wall, instead of saying determine whether it is possible for the stone to hit the wall. I would have gone back and edited the PDF itself, but I thought I had already shared it with everyone and I'd already recorded, so I thought it's best if I do it this way. I hope that didn't cause too many disruptions. And obviously I'm trying my best to create questions, but I might make mistakes every now and then. But I hope the paper is still very useful for your preparation for tomorrow. And we can get started with question 1. So again, starting off with a large data set. So they're investigating the daily mean visibility using the large data set for Herd in 1987. So how could we use a random number generator to create this sample? So all we have to do here is say that we would have to label it. So you would have to allocate a number to each of the available days in Hern. So we would say allocate a number for each of the days. So that'll be, for example, 1, and then it'll go to the number of days. Then afterwards, you have to use a random number generator. Then use a random number generator to produce random integers in that range. So to produce random integers in that range. So then this part is quite important. So you'd obviously have to say select the first 30 values, but you actually have to say select the first 30 distinct values, because it's important that there aren't any repeats. Select the first 30 distinct numbers, ignoring any repeats. So I'm just going to say that just in case. I did kind of repeat myself with saying the distinct and ignoring any repeats, but I'm just doing that just in case. So that's all you'd have to do. So allocate a number for each of the days from one to the number of days, for example, and then you just use a random number generator and go until you pick all of your 30. So that's part A done. For part B, it's recorded. We've got data that is recorded as a dash. So what does that mean, and how should we treat it? So a dash represents no observation recorded for that day. So no observation recorded for that day. Okay, we don't really have to say why, but then all we have to say is that they, is there a name here? Yes, so Sam should omit that data. So they should just not include it at all. So Sam should omit the data, this data, and it's important that it is not treated as 0. You have to say that, so you don't even include the data at all. Okay, so that's part B done. Now part C, state the maximum possible value for daily mean cloud cover that Sam could find in the large data set. So you should know that daily mean cloud cover goes from 0 to 8, and it's measured in octaves. So all you could say is that it's 8 octaves, because that's the largest possible value. It asks for the maximum possible value, so all you want to say is 8 octaves. So hopefully that's a simple large data set question to start with. And now we can move on to question 2, which is some probability. And we are given that there's A, B, C. A and B are independent, and A and C are mutually exclusive. So first question, find the probability of A intersection B. So probability of A intersection B is going to be equal to probability of A multiplied by probability of B as A and B are independent. So then I can just put this into my calculator, which will give me, so 0.35 times by 0.6 is 0.21. Now it wants me to draw a Venn diagram to illustrate these probabilities. So let's draw this out now. So we know that A and C will not have an intersection. So we can label it like this. So this is A, this is B, this is C. So we know that probability of A is 0.35, probability of B is 0.6. So A, B, C. So if the probability of A is 0.35, well, A only has a single intersection, which we can see here. We know that intersection, we just calculated it to be 0.21. So if we want the whole circle of A to add to 0.35, that must mean that this rest of the shape is 0.14. Probability of B intersection C is 0.15. So I can label this 0.15. And again, using the same logic, the whole of circle B should add to 0.6. So that means that the rest of this shape here, so this area here, is going to add to, so this is going to be 0.36, so this will be 0.24. That's the next part. Now we've been given the fact that probability of A union B union C is 0.9. Okay? Probability of A union B union C equals 0.9. So we can say, we'll start off by saying this is going to be 0.14 plus 0.21 plus 0.24 plus 0.15 plus probability of C minus 0.15, and that's going to equal 0.9. So let me split this up and I'll explain exactly why I've done this piece, probability of C minus 0.15. So all I've done is I've added the individual probabilities here. So you can see I've done 0.14, 0.21, and so on. And I added 0.15, which is part of the C, the circle, which in C. Now, if I was to not include this here, if I was not to include this minus 0.15, I would be double counting the 0.15, okay? Because I'll be doing this plus the circle again. So I would count 0.15 twice. Therefore, I have to subtract it to ensure that I don't double count it. Now, with some simplification, I can see that this is going to add to, so 0.14 plus 0.21 plus 0.24, because the 0.15s cancel. So therefore, 0.9 minus 0.59 is equal to probability of C. So that is going to be 0.31. So we know the probability of C is 0.31. So this is going to be 0.16. Now, let's just double check. This should all add up to 0.9, 0.14, 0.21, 0.24, 0.15, 0.16. That adds up to 0.9. And let's not forget now, the sum of probability should be to 1. So that must mean that outside will be 0.1. So that's part B done, a nice Venn diagram question. And we can now move on to part C. So the probability of not C, given that B occurs. So let's write the formula out. So probability of not complement of C intersection B over the probability of B. So let's think now, not C intersection B. So I'm going to highlight not C in red, okay? So not C will be this value here, this value here, this value here, and this value here, okay? Now it's asking us, when does the complement of C occur at the exact same time as the probability of, as event B? So I'm going to highlight event B in blue. So this is event B, and this is event B. So we can see here there's only two events that occur at the same time. So at the same time as a complement of C. So there's only two events. So 0.24 and 0.21 are in B, and they occur in C at the same time. Sorry if that was a bit confusing, but I've highlighted them so I can add them up. So probability of complement of C intersection B is 0.45, and the probability of B is just all three of those values. So 0.24 plus 0.21 plus 0.15, and we know that is 0.6. So that is going to give me 45 over 60, which is 3 over 4. So some nice conditional probability there. I feel like if you use that logic of splitting up the events, looking at complement of C and then looking at B and just seeing where they intersect, that can kind of help you visualize exactly what you're looking for. And that's just a trick that I've always used to help me understand it. So that's question 2 done. So now we can move on to question 3. So question 3 is now our correlation question. So for anyone who had the old paper and hasn't tried this yet, please have a go at this now. And we can start going through it. So our first part is just finding the value of the PMCC between X and Y. But we have to be careful here and not just plug in these values, because it clearly says here that we've coded it so that Y is log 10 of P. So when using your calculator, remember to take the logarithm of each of those P values. So I'm going to substitute it into my calculator. So I'm going to substitute in 1, 2, 3, 4, 5, 6. And I have to substitute in now, not 180, but log 10 180, log 10 450, log 10 710, log 10 120, and so on. And that should give me a value of R is equal to 0.9943 equals 0.994 to 3SF. Now for part B, tested the 1% level of significance whether there is evidence of positive correlation between X and Y. So important, first of all, let us define our hypotheses. So H1 would then be P is greater than 0. And we've got 6 values here. So N equals 6, 1% sig level, and it's a one-tailed test. So my critical value from the table is going to be 0.8343. Now, if we look at the value that we calculated in part B, this is clearly greater than this. So 0.994 is greater than 0.8343. So therefore, we can say that we can reject H naught. So we can say reject H naught. There is insufficient evidence to suggest. So remember to give your conclusion in context to suggest that. So it's asking us that there is insufficient evidence to suggest that there is no correlation between X and Y. Correlation between X and Y. So before we move on to part C, I did spot a mistake in the mark allocation here. So I see that it said 4 marks, but actually should be given 1 mark. So I'm not entirely sure where that came from. It does mean the mark allocation overall will be a little bit different. So for anyone who got a bit confused with that, I'm sorry. It is just simply taking the values that it gives you from your calculator and then inputting it into the equation. So the answer, so we should get Y equals 2.076 plus 0.25026x. And I'm going to round this to 3 significant figures. So 2.08 plus 0.250x to 3 significant figures. Okay. So for part D, they want us to find the values of the constants k and b. So we know that we have p equals kb to the t. So I'm going to take the logarithm of both sides, and I'm going to use the law of logs in the same step here. So I'm going to split it up and use the power rule. So I can write it like this. And let's write down the equation we just found to compare it. So just as a note, I'm not going to use the rounded values when I'm going to calculate my constants. I'm going to use the unrounded values. So log k equals is 2.076. I'm going to use my calculator here, 87641. Oh, sorry, 461. So I'm going to say k is 10 to the power of this number here. So I'm going to put that into my calculator afterwards. And we can say log b is equal to 0.250. So b equals 10 to the power of 0.250. And what we're going to do now is we're going to calculate these. So 10 to the power of 2.0768741 will give me 119.3. So k is 119.3. So k is 119 to 3 significant figures. And we get a value of b is equal to 1.77. So 1.778. So b is equal to 1.78 to 3SF. Now for part E, it wants us to use the regression line to calculate the population of bacteria after 8 hours and comment on the reliability. So when x is equal to 8, we should get y is equal to 2.08 plus 0.2508. So y is roughly equal to 2.08 plus 8 times 0.250. That roughly gives us 4.08. Okay. But however, so does it ask for anything else? I think it says estimate the population of the bacteria. So if y is 4.08, we know y is equal to log 10 of p. So that means that p equals 10 to 4.08. So p is equal to roughly 12,022.644. I don't think it gives a, yeah. So it equals, we can say to 3SF, that's going to be 120. So 12,000 to 3SF. Okay, so now, is this reliable? Well, we can see here the data range is between 1 and 6. So a value of 8 doesn't lie in the range of 1 to 6. Therefore, this is extrapolation and is unreliable. So that is now, I believe that was question 3 done. So again, I'm sorry about the misunderstanding with the marks. There should be 1 mark allocated for that. Hopefully that didn't cause too many problems. And we can now move on to question 4. So it's asked us, so we've been given the lifespan L months. It's normally distributed with mean, mu, and standard deviation. And we've been given some data, so obviously we have to work backwards again. So we've got a normally distributed variable with mean and standard deviation. And they've given us information about some of the failures. So 10% fail within the first 12 months, and 5% last longer than 48 months. Okay, so L is in months. So we can say, well, the probability that L, so the lifespan, so the probability that L is less than 12 is equal to 0.1, and the probability that L is greater than 48 is equal to 0.05. So as I've got the standard scientific calculator, I'm going to swap around the right-hand expression. So I get probability that L is less than 48 is equal to 0.95. So now I can do my standardization. So probability that, so I can say, well, L minus 12 minus mu over the standard deviation is equal to, well, we have to now do some inverse normal. So if we go into our inverse normal, set it equal to 0.1, that gives us an answer of minus 1.2815. And if you've watched my previous videos, I like to store my values because it's much easier. So I'm going to store this to A. We do the same on the right-hand side, inverse of 0.95, and we get 48 minus mu over the standard deviation is equal to 1.6448. I'm going to store that to B. So we can rewrite our equations now. 12 minus mu equals A sigma. 48 minus mu equals B sigma. So now what we can do is we can do equation 2 minus equation 1. And that gives us 36 is equal to A minus B sigma. So therefore we get 36 over A minus B. So we should get now an answer of 36 over A minus B gives an answer of 12.3. I think maybe I've... Oh, sorry, yeah. I just noticed here that there should be B minus A, not A minus B. So I was wondering why that gave me that it was the wrong way around. Sorry about that. So now, yeah. So I get 12.3017. And so if I round this to just 3SF, that's 12.3 to 3SF. But I'm going to store the original answer in C, just in case I might need it later. And now we can just use, so we can substitute that into 1. And we're going to get 12 minus a standard deviation equals mu. So mu is equal to 12 minus AC. And we get 27.765. So that's 27.8 to 3SF. But again, I'm going to store my original value in D. So nice inverse there. So finding your original parameters for the normal distribution. And part B now is ask us find the probability that exactly 3 of these components fail within the first 12 months. So I can see here that we're going to have to be using binomial distribution. So I'm going to define a new variable. So let x be the number of components that fail in the first 12 months. And if you look at the information they gave before part A itself, we know the probability of a component failing in 12 months. So we can write the distribution as out of 25 components, the probability is 0.1. And find the probability that exactly 3 of them fail. Well, we can say that is equal to, so probability that x is equal to 3. So now we use our calculator for binomial PD. 3, 25, 0.1 is 0.2264, which is 0.226 to 3 significant figures. So now part C, find the probability that fewer than 5 of these components last longer than 48 months. So again, we're going to redefine the variable. So let y be the number of components that last more than 48 months. More than 48 months. So y is normally distributed, and I believe we have the same sample size of 25, and we know that it's got a probability of 0.05. So 25 is 0.05. And probability that fewer than 5 last. So probability that y is less than 5 is the same as the probability that y is less than or equal to 4. So we're going to use binomial CD now. So 4 and a new probability of 0.05. And that gives us 0.99283 equals 0.993 to 3 significant figures, because I don't think it gives any accuracy there either. So now, part D. State the values of L at which the point of inflection of the normal curve occur, and state the proportion of data that lies within 1 standard deviation of the mean. So it's important that we know where do the points of inflection occur on a normal curve. So if we just draw just a standard, so just assume this isn't representing the data we have, this is our mean. The points of inflection occur at the following points. So mu plus the standard deviation, and mu minus the standard deviation. So the point of inflection, if we use the values that we had, so they're going to occur at, if we think about it in terms of my letters, it'll be D plus C and D minus C. Okay, so if I put that into my calculator, that'll give me 40.1. So it'll be mu plus the standard deviation equals 40.1 to 3SF, and mu minus sigma, which is D minus C, which is 15.5 to 3SF. And again, so this is some knowledge here. So what is the proportion of data that lies within 1 standard deviation of the mean? Well, in the textbook, it says that 68%, so approximately 68%, lies within 1 standard deviation of the mean. So we can just write 68% is the proportion. We don't really have to say anything else. Okay, so I just don't need to box that. So that's part D done. And now we can move on to question 5. So I believe this should be our last question for statistics. I might be wrong. But now we've got another normal distribution question. So a machine fills bags with flour. The mass of flour in a bag is modeled as normal distribution with standard deviation 8. So I can see here we've got a hypothesis test now. So standard deviation 8, and they've given it as x, and it's supposed to be set that the mu is 500. It suspects that it's underfilling the bags, so that gives us a hint as what our hypothesis is going to be. And the null hypothesis is rejected if the sample mean is less than 496.5. The inspector carries out a hypothesis test at the 2.5% significance level. State your hypothesis clearly and find the minimum required sample size n. So let's start by defining our hypotheses. So H0 is that mu is equal to 500. H1, so alternative hypothesis is mu is less than 500, because it says that they suspect that it's underfilling the bags. So I'm going to assume that H0 is true. So assume H0 is true. So x normal 500, the standard deviation is 8. So it'll be 8 squared. Now we're going to take our sample size of n, but keep in mind we don't know what n is. So it'll be 8 squared over n. We know that we're going to reject if the sample mean is less than 496.5. Okay? So we know that our sig level is 2.5%, and it's one-tailed. So I know that I'm going to have to reject. If we use the tables, we can see that we're going to have to reject if our z-score, because at the 2.5% significance level, we reject if z is less than minus 1.96. Okay? And we know that our critical region is 496.5. Okay, because it says here the critical region, if it's less than 496.5. So I should rewrite this as x bar less than 496.5. So what we want is, if we standardize this now using this, so we obviously want this to be less than, because we want to reject. So we want to be less than minus 1.96 because we're trying to reject. So let's sub in our values now. 496.5 minus 500 over 8 over root n is less than minus 1.96. So I can write this as root n. So 496.5 minus 500 is minus 3.5 over 8 is less than minus 1.96. So root n is greater than, because we're going to do minus 1.96 multiplied by 8 and divided by minus 3.5. So we'll get root n is greater than 112 over 25. Now let's square this, and we're going to get n is greater than 20.0704. So min of n, so minimum value of n is 21, because it has to be an integer. We can't take 20.5 samples. So hopefully that makes sense. We did do a similar question, I believe it was in the last video. So hopefully this was just another recap. Part B now. The inspector takes a sample and finds the sample mean is 497.1. State with the reason the conclusion of the test. So 497.1 is clearly greater than the critical region of 496.5. So the sample mean is not in the critical region. Sample mean does not lie in the critical region. So then we can say except H0. So we can say that there is insufficient evidence to suggest that the bags are being underfilled. So there's insufficient evidence to suggest the bags are being underfilled. So I can say don't reject. I'm going to say in brackets, don't reject. Do not reject H naught. So that's part B done. Part C, state the actual significance level using your value of n. So the actual significance level is just the probability. If you remember when we did in binomial, the actual significance level of the test is just the probability of your critical region occurring. So it's the probability of x bar being less than 496.5. Okay, so we're going to use our values here. So 7, normal CD. So I'm going to say my lower bound is just, I'm going to put a massive negative number, 496.5. Now my standard deviation is going to be 8 over root 21. So 8 over root 21. And my mean is going to be 500. And that gives me an answer of 0.02248 equals 0.0225 to 3 significant figures. Now, part D, state one assumption made about the sample taken by the inspector. Well, you would have to take the bags in the sample randomly. When you're doing a hypothesis test as well, it's important, or with these distributions, you have to say that the bags are selected randomly. Now, part E. So there's one reason why in practice it may not be possible to take a random sample of bags from the machine. So I've always hated these questions because, you know, you have to always say some really weird things just to get the mark. But all you have to say is, if you think about it in context, we've got a machine, so they're taking samples from the machine. So all you could say is that if the bags are coming continuously from the machine, it's truly difficult to select them randomly. So for example, it is difficult to take a random sample of bags continuously flowing out the machine. That's what I mean. So if you think about it, if you've got a machine that's outputting things on a production line, if we think about random sampling from year 1, I believe, it's not really possible to randomly sample that. He's just going to pick up, and that's not truly technically a random sample at that point. So that's part E done of question 5, and that is now statistics done, I believe. So we can now move on to our first question in mechanics. So at time t seconds, a particle of mass 0.4 kg is moving on a horizontal plane, and we've been given the position vector. So find the velocity at time t. So we know that the velocity is the derivative of r with respect to t. So we can take the derivative of this, because that is going to be 6t squared minus 18t plus 12, and it will be 8t. So this is going to be the velocity at time t. So for part B, they now want us to find the time when p is moving parallel to the vector j. And if we think about, if it's moving parallel to j, it means that we're not moving in the I component at all. So our I component of the velocity should be equal to 0. So 6t squared minus 18t plus 12 is equal to 0. So divide by 6. T squared minus 3t plus 2 is equal to 0. Now this factorizes perfectly to give t minus 2, t minus 1 is equal to 0. So it's at t equals 1 or t equals 2 seconds. So now part C, find the magnitude of the resulting force acting on P when t is equal to 2. So if we remember now, we're going to have to find acceleration. So let us now take the derivative, again, of velocity. Okay, because when we're working with forces, when you see the word force, you should be thinking about F equals ma. So acceleration is the derivative of v with respect to t. So that's going to be 12t minus 18 over, and then 8 meters per second squared. So when t is equal to 2, acceleration is equal to 6, 8 meters per second squared. So 6I plus 8J meters per second squared. So the resultant force, so F is equal to M times A. Okay, what we can do is we can just take the magnitude of A. So we just use, that's going to give us, so it's 6, 8, so 36 plus 64 is going to be 100. So if we do root 100, that should give us 10. So we're going to say F is equal to the mass, which is 0.4, times by the magnitude of the acceleration. Okay, so then I'm going to say, well, then that means that F is equal to 0.4 times by root 36 plus 64. So F is equal to 0.4 times 10. So F is equal to 4 newtons. So that's how I did it. Finding the magnitude of the resultant force, you just have to remember to take the magnitude of your acceleration and then substitute it in to F equals ma to give you your final answer. So now we can move on to question 7, which is giving us some information, and okay, we just have to prove one of the formulas. Okay, so if we just draw a quick diagram here, it's elevated, so it's angle alpha. We can think about this as u. That's the speed that it's projected at. Okay, so we're going to label, so it uses x, yeah. So we can let the horizontal distance be x and vertical distance be y. So we knew that horizontally there's no acceleration. We always use x equals ut. So we can say x is equal to ut. Now, what is our horizontal component of the velocity? Is u cos alpha, because we can break down this triangle to get u cos alpha. So x equals u cos alpha t. Now with the vertical one, it's a little bit more complicated because we have to account for acceleration. We have to account for gravity. So if we think about it, if we draw out our shopping list here for the suvat, so we've got y. Our initial velocity is u sine alpha. We don't really care about the final. We know acceleration is going to be minus g. And time, we're not really concerned about time yet. Actually, instead of saying that, why don't we rearrange the left-hand equation so we get t equals x over u cos alpha, because then that gives us an expression to put here. So let's work with this now. S equals ut plus half at squared. Ut plus half at squared. So y equals x u sine alpha over u cos alpha. I'm going to shift this to the left because I'm worried I might run out of space. Plus, so minus g over 2 x over u cos alpha whole squared. So let's look at what the equation is asking me. I can see that we've got the first part sorted out. So I'm just going to shift this. Let me shift this down actually, because this is our final working out. So y is equal to x tan alpha, and it should be minus gx squared. So let's take the x squared out, and I'm going to put the 2u squared in. So minus gx squared multiplied by 1 over, so over 2u squared 1 over cos squared alpha. Okay, because I can see here I've got gx squared and I've got a 2u squared here. Sorry, the formatting is not too great there. So I can now use an identity which says that 1 over cos squared alpha is sec squared alpha. And now I can use a final identity saying that sec squared alpha is equal to 1 plus tan squared alpha. So therefore, y equals x tan alpha minus gx squared over 2u squared 1 plus tan squared alpha, which is exactly what the question is asking there. So gx squared 1 plus tan squared alpha over 2u squared. So now we can move on to part B. A stone is thrown from a point O on horizontal ground towards a vertical wall which is 20 meters away. The stone is projected with a speed of 18 meters per second at an angle of elevation alpha, and it hits a wall at a height of 3 meters above the ground. So we've got 3 pieces of information there. We've got y is equal to 3 because we've got a height of 3. We've got speed of 18, and we've got the distance x of 20. So we can now substitute this into our equation. So we can say, so we've got y is equal to 3, x equals 20. and u equals 18. So 3 is equal to 20 tan alpha minus, so 20 squared is 400 g over u squared. So 18 squared is 324, I think. So let's test that out. Yeah, 324. Multiplied by 2 is 648. And then 1 plus tan squared alpha. So I believe, yeah, it's got it in terms of tan squared. So we're going to do some simplification here. Let's multiply by 648. So 3 times 648 is 1,944. We do 648 times 20. That gives us 12,960. Minus 400 times 9.8 is 3,920. So it'll be 3,920 minus 3,920 tan squared alpha. So am I seeing any? Okay, so it's clearly going to have some simplification here. But let's just rearrange till then. 3,920 tan squared alpha minus 12,960 tan alpha equals, so 1944 plus 3,920 plus 5,864 is equal to 0. So we know that we're going to have 196. So let's see, how do we get to 196 from 3,920? We can divide by 20. So we're going to divide the whole thing by 20. So we're going to get 196 tan squared alpha. 12960 divided by 20 gives us 648 tan alpha. And then 5864. 5864 divided by 20 gives us 293.2 equals 0. So let's check again. So 196 tan squared alpha minus 648 tan alpha plus 293.2 is equal to 0. So that is our show that done. Now, determine whether it is possible for the stone to hit the wall at this height, fully justifying your answer. So we have to determine, so although it does say the stone hits the wall, we have to show that it is possible. That's all it's asking us. So let us find out the solutions for this. If we use the discriminant here, so b squared minus 4ac, that is equal to 648 squared. So 419904 minus 496, 293.2. So I did say you find the solution, so you can do finding the solutions, or you can use the discriminant. And I'll explain that in a second. So we're going to do minus 196 multiplied by 293.2. And that gives us an answer of, this is just a positive answer. So 190,035.2. So as b squared minus 4ac is positive, there are two real roots to this equation. What I am going to do quickly is I'm going to check that these roots are positive. Because it is involving tan, I think it's safer to make sure that these roots are possible. So I'm going to substitute this in, 293.2. I'm going to store both of my answers, and I'm going to take the tan inverse of both of them. So if I take the tan inverse of A, I get 70 degrees. Tan inverse of B, get 28 degrees. So I can clearly see that it is possible. So there are two real roots to this equation. Therefore, it is possible. It is possible for the stone to hit the wall at a height of 3 meters. And, well, I'm just going to give the angles here. So alpha is equal to 28.4 degrees to 1 dp, or alpha equals 70.1 degrees to 1 dp. So I understand that might have been a bit confusing. The wording wasn't too great because it does say the stone hits a wall. So I should have said that, show mathematically that it is possible. But hopefully that method does make sense. In an exam, they would obviously phrase that much better. And we can now move on to question 8. So for question 8, we have a car of mass 1,400 kilograms towing a trailer of mass 600 kilograms up a straight road inclined to an angle theta, and sine theta is 1/14. So the car and trailer connected by a light rigid tow bar. and it's parallel to the road. And we've got a constant resistance. So the car has 400 newtons resistance and 200 newtons resistance on the trailer. And we've got a constant driving force of 3,200 newtons. So let's start by drawing a diagram here because that would definitely help us out. So we incline at theta. So we've got a car of 1,400 kg. So this is 1,400. And then we've also got a trailer of 600 kg. So just assume that that's touching there. So that's 600G. 600G here. And we can resolve there. And then we know that we've also got a driving force of 3,200. And we've got our tensions. But we also have our, it might help to maybe make this a bit bigger because there's not enough space here. So we extend it so it's over here. Sorry, let's just fix this diagram. Okay, so we have 600G. We've got our tension. We also have our constant resistive force of 400 on the car. So 400 and 200 on the trailer. Okay, sorry, that's the wrong way. 200 here. Okay, so we've got 400 and T, which is resisting the car, and then 200, which is resisting the trailer. And we know that sine theta is 1/14. So we can draw a triangle here. So this is root 195 if we use Pythagoras' theorem. So now it's asking us to find the acceleration of the system. So what we can do is we can just use Newton's second law. So we can use, which is F is equal to ma. So the resultant driving force here is 3,200. Now everything else we can see here is opposing it. So we can do subtraction of. Now let us find the horizontal components of the weight. So we can label this angle here as theta. So that's theta and that's theta. The top angles are theta. Let me make this a bit clearer. This angle is theta and this is 600G. Okay, so we can, the car's horizontal component is going to be 1,400G sine theta, because that is this line here. And the trailer's horizontal component is going to be 600G sine theta, because that is, that is this line here. Next, let's add the resistive forces, which will be 400 and 200. And that's equal to the mass times the acceleration. So the total mass here is 2,000. So it'll be 2,000 A. Let's do some expansion here. So we're going to substitute in our value for sine theta, which is 1/14. And we're also going to multiply by G. So that's going to give us, if we do this all in one step, so I'm going to say use G equals 9.8 and sine theta is 1/14. So if I substitute this now into my calculator, so I'm going to use 3,200 minus 1,409.8 times 1/14 minus 609.8 times 1/14 minus 400 minus 200. That gives me 1,200. So 1,200 equals 2,000 A. So A equals 12/20 equals 6/10. So therefore A is equal to 0.6 meters per second squared. So that is our acceleration of the system. Part B is now asking us to find the tension in the tow bar. So what we can do is we can just isolate the trailer. So we're going to use Newton's second law on the trailer. So we know that we've got tension is our, like you can think about it as your driving force. So we can do T minus, so we're using F equals MA here, so I'm just going to write that out, F equals MA. So T minus, now what is opposing it? 600G sine theta and the resistive force of 200. And we know the mass is 600, so equals 600A. So we can substitute this in now, so we can use our value for, so we're going to do 600, 9.8 times by 1/14, and we're going to do subtracting 200. So we get T minus 220 equals 600A. So we're going to use the fact that A is 0.6, so we get 600 0.6 plus 220. So we get 580 newtons. So let me just double check that I haven't made a mistake here. So 609.8 times by 1 over 14. Sorry, yeah, I did make a mistake here. So there should be 620. It's because what I did was, I actually put minus 200, but it should be plus 200 in my calculator. So that instead gives me 600, 0.6 plus 620 equals 980, not 580. 980 newtons. So that is part B done. Part C is find the distance. So it says here, when it's traveling at 12 meters per second, the tow bar brakes. The driving force of the car's engine remains constant. And find the distance the trailer travels from the instant the tow bar brakes until it comes to instantaneous rest. Okay, so we know that it's traveling at 12 meters per second. So let's find, if we write out our shopping list here, so you'll see that list. So we know we're trying to find S. We know the initial is going to be 12 and the final is 0. We don't care about the time, and we're trying to find the acceleration. So let's find the acceleration here. So the tow bar brakes. So now that means the trailer is a separate, it's kind of a separate entity from the car. So we no longer have the tension. Okay, so if we think about a new diagram here, I'm going to completely ignore the car here. So this is just for the trailer. We've got our trailer here, 600G. And now we only have the resistive force of 200 here, as well as the weight. And we've got an angle of theta. Let me just make sure it's 200 resistance. Yes. So now let's work out the acceleration. So using Newton's second law, 0 minus 200 plus 600G sine theta. So again, finding the horizontal component of the weight is equal to the mass times acceleration. So 200 plus 600, 9.8 times by 1 over 14 is equal to 620. So we get minus 620 equals 600A. So that means that A is equal to minus 620 over 600 equals minus 31 over 30. So A equals minus 31 over 30 meters per second squared. So we can substitute that in here. So minus 31 over 30. Now we can use our Subat equation. So we're not going to use S equals UT plus half AT squared. We're going to use V squared minus U squared equals 2AS because we don't actually have T. So 0 squared minus 12 squared equals 2 minus 31 over 30 S. So minus 144 equals minus 62 over 30 S. So S equals minus 144 divided by minus 62 over 30. And that gives me an answer of roughly 69.677. So S equals 69.7 meters to 3SF. So I don't think it's specified an accuracy. Yeah, it doesn't. And for part D, they are now asking us to state how the model will be refined to make it more realistic regarding the air resistance on the trailer. So actually, instead of modeling, because they say the resistance to motion is modeled as having 200 newtons, but in an actual scenario, we won't have constant resistance. So we should model the air resistance. So model air resistance as proportional to the speed of the trailer. It's proportional to the trailer speed instead of constant. Okay, so that is now the penultimate question done, and we can now move on to the last question, which is question 9. So for our last question here, we have a nice hinge question. So we've been given a uniform rod of mass 2m and length 4a, and it's freely hinged to a vertical wall at the point A. And the rod is held in equilibrium at an angle of 60 to the upward vertical by a light and extensible string. And one end of the string is attached to B, and another is attached to C on the wall. And the string is perpendicular to the rod. So this is a difficult one to visualize. I purposely left out the diagram to kind of challenge you to think, how is this going to work? So that is our wall. If we draw our rod, this is our rod AB. So A, B, and we can see here, or actually I might make this a bit shorter because we have to make it perpendicular to the wall at B. So if we think about it like this, or I might make it shorter again, just so I can make it perfectly perpendicular so it's easy to see here. So B, and this will be our point C. And this is our string, so we're going to have tension acting this way. Now AB is a uniform rod of mass of length 4a, and it has mass 2m. But before I draw that, I'm going to see here that we've got another particle which is attached to the midpoint of AB as well. So that would be the exact point where the center of mass is. So instead of writing 2m, I'm going to write 3mg downwards. This is 2a, this is 2a, and I'm going to write this here. Let's make that a bit clearer. So 2a and 2a. And there is no more information here except from the the reaction forces. So I'm going to have one reaction force going upwards. So I'm going to label that reaction Y. And I'm going to have one going across. So reaction X. And I'm going to label this 2A here. And I'll label this also 2A. Okay, so now that is our labeled diagram. And now the first part is asking us to find the tension in the string in terms of M and G by taking moments about A. So if we're taking moments about A, so this is held in equilibrium. So we can say clockwise moments is going to equal to anti-clockwise moments. Okay, so we can say if we take moments about A, the clockwise moments are going to be if we first look at tension. So I'm going to say, well, tension is perfectly perpendicular to the rod. So I don't have to resolve yet. So I can just say that the anti-clockwise is going to be 4TA. 4TA. Now let's look at the clockwise moments. We are going to have to resolve the mass. So we take the component that is perpendicular to the rod. Let's draw the triangle out again. So if I just copy paste this diagram here, so I can explain how we can find the angle as well, which is going to be useful for the calculation. So we know that this angle here, which I forgot to label actually, is 60 degrees. That is 60 degrees. Okay, that means that this angle here is 30 degrees. But let's think about it now. If that is 60 degrees, this line here, there's a blue one, is going to be an angle of 30 degrees. Now, if I continue to draw this line across, we can think of that as a right angle triangle. So if it's a right angle triangle, the blue line, it represents 30 degrees. This line here must represent 60 degrees as well. Okay, and you can also think about that by doing Z angles, or you can do it how I said it. And again, if I draw in red here, this is a right angle. You can see here that's a right angle. So if that's a right angle, then the angle on the inside, so at the top of this triangle here, so if you think about it like this is going to be 30 degrees. Okay, so blue line represents 30, the green line represents 60, and then the red is showing the right angle, and because it's a right angle, the inside must be 30 degrees. So that means that the perpendicular component of the weight is going to be 3mg cos 30. So 3mg cos 30, but let's not forget to multiply by the distance of 2a, is equal to 4TA. So that means that 6mg cos 30 equals 4t, because I cancelled out the a's. So t is equal to 3 over 2 mg cos 30. Cos 30 is root 3 over 2. So that is equal to 3 over 2 mg times root 3 over 2. So t is equal to 3 root 3 over 4 mg. So that is part A done. Hopefully the explanation of the angles made sense. And we can now move on to part B. So it's asking us to find the magnitude of the resultant force exerted by the hinge on the rod at A. So again, what we're going to do is we're going to find Rx and Ry, and then I'll explain how we can find the resultant force. So the best way, in my opinion, is to resolve horizontally and vertically. So if we look at resolving vertically first, we can see that we have two forces acting upwards. One of them is Ry, and another one is the vertical component of T. So now I'm going to draw this triangle here. This is a right angle. And so this here is 60, as we said. So that means this angle here is 30. Okay, So this angle here is 60 degrees. Now let's think the vertical component of t is going to be t sine 60. So ry plus t sine 60. And the only thing that is going downwards is 3mg. And we don't have to resolve it because it's perfectly down. So ry equals 3mg minus t sine 60. So ry equals 3mg minus t, which is 3 root 3 over 4 mg times by root 3 over 2, because sine 60 is root 3 over 2. So let's do some simplification of that fraction. So 3mg minus, so root 3 times root 3 is 3. So it'll be 9 over 8 mg. So ry is going to equal to 15 over 8 mg. Now finding rx, we can just do the same thing. So we can resolve horizontally. So we can look at the horizontal components. So if we do the same thing, we can look at the horizontal component of the tension, which is going to be t cos 60. And the only other thing acting horizontally is the resultant force x, so Rx. So we can say is equal to Rx. So Rx is equal to, so cos 60 is going to be a half. And the tension we calculated was 3 root 3 over 4 mg. So Rx is equal to 3 root 3 over 8 mg. So if we think about this diagrammatically, we had drawn, this is Ry, and this is Rx. If you had watched some of my previous videos, you know that we can't just, technically, that isn't our magnitude. What we have to do is, so let's get rid of this, we are going to have to think about it like this. Okay, so that's still Rx because it's in the same direction. And we will now join this to Ry, and that is going to be our resultant. Let me make that a bit clearer, because that's what it's asking for. It's asking for the magnitude of the resultant force. I can label that Rf, and I can label this Rx. So we're going to use Pythagoras, and we'll say Rf is equal to the square root of Rx squared, so 3 root 3 over 8 mg whole squared, plus 15 over 8 mg whole squared. So Rf is equal to 27 over 64 mg squared plus 225 over 64 mg squared, square rooted. So I'm going to factorize out the mg, okay, because that's in both of them. And if we just square root a square, it will just become itself. So become mg root, so 225 plus 27 is 252, and the denominator stays the same. So root 252 over 64 becomes 3 root 7 over 4. So it becomes 3 root 7 over 4 mg. And I believe it said it was in, yes, so k is an exact third. So we can say k is equal to 3 root 7 over 4. Now moving on to the final part, so part C. And it's asking us to find the exact angle that the resultant force exerted by the hinge makes with the upward vertical. So if we think about it again, now if we draw it onto this diagram, what I drew below, so we draw this line here because that is Rx. And we found the resultant force now. We are trying to find an angle that I'll highlight in red. Okay, so we're trying to find that angle here. So what we can use is we can use the tan. We can use tangent. So we can say, if we label this to be, I believe they haven't used theta, so we can use theta. So we can say, well, tan theta is going to be the Rx over Ry. So tan theta is equal to, so Rx we calculated was, sorry, I'm losing it. So 3 root 3 over 8 mg. But then we're going to divide it, so times it by 1 over Ry. So times it by 8 over 15 mg. So we can now simplify this to 3 root 3 over 15. Okay, so tan theta equals root 3 over 5. So theta is equal to the arctan of root 3 over 5 degrees. So that is the last question of this paper. And I hope this was useful. Again, I apologize for a couple of the errors that were in this paper. So the some of the incorrect mark allocations and some of the wording the questions could be improved on. So again, I'm sorry for that. I do try my best. Obviously, I'm not an official Edexcel examiner, so maybe I'll make a couple of slip-ups. But nonetheless, I hope this was useful. So all the best for your exam tomorrow. Any other questions, any topics you're still worried about, I can possibly create a set of questions for you to practice. And if this is useful, please share and subscribe, because that'll help me out a lot. And for a lot of you, it's the last exam. So just one final push and then you can have a well-deserved rest. And apart from that, if you could share this with people who are going to be doing their A-levels next year, that'll be a really big help to me. And all the best for tomorrow.